Welcome to the ET420 PIC LabX-Demo Lab. Okay, I'm back at MP Lab, and this is a continuation from our first video, the startup for our MP Lab. And I've downloaded this, and it's working, and we'll go from there. Our first modification in this lab is to modify the program and use while 1 equals 1 and use the RD1 command to light only LED RD1. Okay, let's do some modifications that were requested in the lab. So first thing we're going to do is go equals 1. So this while loop is a continuous loop between these two braces here, and anytime this is true inside this parentheses, it's going to continuously rotate. Okay, so the next thing it wants us to do is to light RD1 with the RD1 command. So what we have here is port D, and this is in hex, and this is all digits. So what we can do, 0x is hex, and 0b is going to be binary. So we have, this is an 8-bit processor, so we're going to have 8 bits, and we want to light the first one. So we could put this in binary, and this will also work, but what it asks us to do is use the RD1 command, RD1, which is that RD1 bit equals 1, and we could go ahead and run it and program it, and that's good. Let's take a look at it. And this warning is going to come up all the time unless we click it off. And we're programmed. Here I'm showing the correct result of our program, and we have RD1 on. The next part wants us to modify the program for using a for loop, and this is a continuous loop. It's another way to do the while command, and we want to use the port D command to light only LEDs 0 and 2. Okay, let's do it. Okay, let's modify the program as the lab's requested. So we're going to change our while to a for loop, for. Inside the parentheses, we're going to put in 2 semicolons. Okay, so that's the same as a while 1, loop forever between these two braces. So let's go ahead and, this is not what the way the lab asked, but this is another way that we could do this. So we could do RD0 equals 1 and RD2 equals 1. Again, ignore these little light bulbs on the side. Ours is an older microprocessor. It doesn't meet the new programming standard. So this will work. And it asks us to do the port. So let's go ahead and do a port D. And there's 2 ways we could do that. So we could do it in binary, 0B. Put our 8 bits out there, and let's get rid of this. And this here is a comment, so don't worry about that. We can make it anything we want. It does not affect the program. Okay, so we wanted 0 and 1. 0 and 2, sorry. Okay, and there's another way we could do this. Let's go ahead and do it in hex. So 0x, and this part would be 0, and this part is 5 in hexadecimal, right? So we go 0, 5, and that will also work. So let's go ahead and erase this and just use our binary, and let's run it. Okay, and I'll be back. Here's our correct program that for LEDs. those are the correct ones, RD0 and RD2. And the next one, we need to create a new project and download our LabX-Demo 2 program. And it should flash all LEDs at half-second intervals. Okay, so let's create a new project and open up our file. So we need to go to File, New Project, Microchip Embedded, Standalone Project, next. All families, let's go down to Recently Used, and it comes up with 877, good. And we're going to use our ICD3, and we're going to use our XC8 programming. And here we're going to call our project name LabX Demo 2. Okay, and it's going to go back to our folder, good. And we're going to finish. And we need to go to Source Files. We're going to right click, Add Existing Item. We're going to go back to our file where everything's at, and we're going to open up our second program. Select and open it, and let's get rid of our first program, and we're there. Let's go through our program. So the first part of it's the same. So here's our configuration files. We need to have the crystal frequency because we're going to use the timer, and our A to D's are digital, and we're going to clear tri-state D and port D. And here's our continuous loop, which is going to go between those two spaces there. And port DFF is going to turn all the LEDs on. Port D00 is going to turn all the LEDs off. And delay my milliseconds 500 is going to be 500 divided by 1,000. So it's going to delay at a half second. And we'll go ahead and program it. And here are all of our LEDs flashing at half-second intervals. The next thing we need to do is modify the program to light odd LEDs at 1 second intervals. Okay, let's modify our program here, and it wants odd ones, so let's go to binary. Put 8 bits out there, so 1 would be odd, 3 would be odd, 5, and 7. And let's make this 1,000 for 1 second. And we could change our comment if we wanted to. And let's go ahead and run it. And here's our odd LEDs flashing. Okay, here's part 3A, where we're going to make a new project and upload our LabX-Demo 3. And it should, when we push switch 1, it should turn on LED RD1. And when we push switch S2, it should be RB5. Okay, let's start a new project and open up our last file. New project, embedded, standalone, all families. Let's go down to recently used, 877, good, next. ICD3, XC8, and we're going to call this LabX Demo 3. And good. And again, we're going to go down to our source files, right click, add existing item, and LabX-Demo 3. Let's open it up, double click on it, get rid of our last lab, and there we are. Okay, here's our program. If I push switch 1, which would be this one in the top corner, I'm going to get RD1 on. If I go to switch 2, which is the next one over, I'm going to get RD2. working perfectly. Now that our Demo 3 project worked, let's go through the program here. So again, we're going to have our configuration files, our crystal frequency, so we could use a timer. XCH is going to bring up our compiler of XC8. These two are for future when we start utilizing text. And here's our main, and again A to D. And here we're setting up our tri-states and our ports in order to work on our switches. And I'll go into more depth next time when we go through our matrix keypad. And again, we're connecting all of our and clearing our tri-state D and our port D. This is going to set up pull-up resistors inside the microprocessor. We'll go ahead and we'll cover that later. And here's our continuous loop. And here we have if, else, else if, and else statements. So if RB4 equals, so we have pull-up resistors, and when I push switch 1, I'm going to pull RB4 low. Okay, when it goes low, I am going to turn on RD1. And it's going to delay for a half second and then turn off and delay for another half second. If it's not RB4 and it's RB5 that gets pressed, we're going to light up RD1, delay half second, turn it off, delay a half second. If we do nothing, it's going to go to port D, which is off. So if we don't push a switch, it's just going to go off. So this is an if-else statement. So if this, then do this. Else if this is it, do this. If it's nothing, do this. Our lab is asking us to modify it to use switch 1 for all LEDs at a quarter second. And switch 2 would be for flashing all LEDs at 1 second intervals. Okay, so let's modify our program in order to match the lab. So let's go ahead and we're going to use port D equals, and we want to make all odds flash. So let's go ahead and use 0B. And we need our 8 bits. One more. Okay, so we're going to make our odds. So 1, 3, 5, 7. So we want a quarter second, so that's 250 divided by 1,000 to get 250, which is a quarter second. Good. And the next one wants us to do all, so let's do port D equals 0x hex, so we're going to go FF. Good. And that should do that. And this one's supposed to be for 1 second. And this is for 1 second. Good. So, and this will leave them off if we're not pushing a switch. So let's go ahead and program it. Okay, let's test it. So switch 1 should flash the odds at quarter second. Good. And switch 2 should flash them all at 1 second intervals. So both perfect.